discussion first. What topic we can cover in our complete VPN section? So this section is totally dedicated for VPN implementation. Okay, VPN implementation, and these are the VPN implementation topic. Akbar, these
Yes, sir.
are
Yes.
VPN implementation topic,
Okay.
and these are router-based VPN. If you remember in Cisco ASA firewall training and in Cisco firepower training, you can implement side-to-side VPN in between firewall devices, right?
Okay.
Firewall devices. But
Yes.
VPN, the popular VPN option is what? Router-based VPN. Router-based VPN. So these are called router-based VPN implementation. And today we'll focus on first this lab is called LAN to LAN, or you can say site to site VPN implementation. Site to site. This is our topic for today, site to site or LAN to LAN VPN implementation. And this topic is called policy based. This topic is called what?
Policy based.
Policy based site to site VPN. Why it is policy based? And actually we have two options, policy based site to site VPN and we have route based site to site VPN. So first we can focus on policy based first. After that, I will tell you and we can discuss the difference in between policy based and route based. So let's revise our basic VPN concept first. Akbar, if you
Yes.
remember from Cisco ASA session, basic VPN implementation. So wait. So if we talk about VPN implementation, we have two type of VPN implementation, right? IPsec and SSL VPN, right, Akbar?
Yes. 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 Yes, sir.
IPsec, IPsec we are using for site-to-site VPN connectivity. For example, you have two branch office A and branch office B. You want to connect these two branch office over this public network, over this untrusted network in a secure manner so you can establish your VPN tunnel. You can establish your VPN tunnel. This tunnel is what? Site-to-site VPN tunnel. You are trying to connect branch offices. You are trying to connect branch offices. And for site to site, we can go with IPsec option. IPsec. For site to site connectivity, we can go with IPsec. That's why you can say IPsec site to site VPN. Now, what is IPsec? IPsec is a suite of protocol, or you can say in IPsec, we have multiple protocol. They can work together to provide you a secure VPN connection. And if you remember our discussion, IPsec complete configuration is divided into two phases, right? This is
Yes. Yes, sir.
called IPsec phase 1, right?
Yes.
And we have IPsec phase 2. So let's revise our concept again. IPsec phase 1 and IPsec phase 2. So what we can do in phase 1? Okay, we have two branch office A and branch office B. This is your ISP portion. Okay, so in phase 1, what we can do? In phase 1, our first step is we can generate our session key, right?
Yes.
We can generate our session key. What is the use of this session key? We can encrypt our data traffic later on. So we can generate session key. First, we can generate session key. So what are So what I'm doing, I'm trying to generate session key on branch office A. For example, CCNA is a session key. CCNA on branch office B. So we have session key on both branch office. Once you generate your session key, what is the next step? Your next step is to exchange session key in between branch offices. So our next step is what? Exchange session key. And to exchange session key, we can set up our first tunnel. This is called phase one tunnel. So we can set up our phase one tunnel. Through this phase one tunnel, we are not sending any data traffic. Okay. We are not sending any LAN traffic. No. Through phase one tunnel, we are only trying to exchange session key information. Session key information. It means you can say we are trying to establish a bridge first. We are trying to establish a bridge first in between site A and site B. And once bridge will establish, then yes, I can send my data traffic. So in phase one tunnel, we are not exchanging any data traffic, any LAN traffic. We are only trying to exchange our session key. So we can create our first tunnel. This is called phase one tunnel. And to create this tunnel, we require parameters. To create this tunnel, we require parameters. We need what? Encryption, hash, and authentication key. So for encryption, yes, we have some option for encryption, DES. If you are using DES parameter to encrypt your traffic, to encrypt your tunnel, DES will provide you 56 bit of encryption. If you are looking for higher bit, then yes, you can go with triple DES option. You can go with AES, Advanced Encryption Standard. AES is a popular option. Why? Because in AES, we have variation in bit. For example, AES 128, AES 192, AES 256. So why AES is a popular option for encryption? Popular parameter because we have variation in bit size. We can go with the higher bit. So for encryption, we have these parameters. For hashing, hashing will provide you data integrity. And for hashing, we have parameters is called MD5 and what? SHA.
Yeah.
Secure hashing algorithm. SHA is a popular option. SHA is a popular option. Why? Because again, we have a variation in bit size. We have SHA-1, SHA-256, SHA-384, SHA-512. So we have variation in bit size. That's why SHA is a popular option for hashing. Authentication key. For authentication key, we are using a method. We are using a method is called what? PSK. PSK is a method, Akbar.
Yes, sir. Appreciate key.
PSK is a method. Wait. Okay. PSK
Yes,
is a
sir.
method, okay? It's a pre-shared key. Pre-shared key. It means what? It means same session key we are using on both branch office. Same session key. So we have
Yes.
CCNA on branch office A, CCNA on branch office B. Now, this is what pre-shared key is, a method, authentication method. Now, to create this phase one tunnel, we are using a protocol in background. It's called ISA-KMP protocol. ISA-KMP is a protocol to create our phase one tunnel. So this is what our phase one tunnel and protocol we are using ISA-KMP. ISA-KMP works with UDP port number 500. So what is the purpose of this tunnel, this phase one tunnel? To securely exchange session key. We are trying to establish a bridge first in between site A and site B. And once bridge will establish, then yes, I can go with phase 2 tunnel. I can send my data traffic, I can send my LAN traffic. So now phase 2 tunnel is totally depend on phase 1 tunnel. Totally depend on phase 1 tunnel. If there is any issue in phase 1 tunnel, you cannot establish phase 2. No. So to create phase 2 tunnel, wait. I'm trying to create here a phase 2 tunnel. So to create phase 2 tunnel, you need two parameters, encryption and hash. Encryption and hash. And protocol is required for phase 2 tunnel is a ESP protocol, encapsulating security payload. Clear this basic option, Akbar?
Yes, sir. Very clear, very
Remember?
clear.
Okay.
Very clear, very clear.
So now let's create a topology. Okay. We are trying to do our first lab. And these are what router-based VPNs. Router-based VPN. So let's create a topology. Let's create a topology. Wait. So we have site A branch office and site B branch office. Into this small topology, this R2 router is acting as a ISP router. So you can connect a cable. This R2 I'm using as a ISP, so we can use a symbol here, cloud. This is ISP router. We have site A branch office. This is site A. Site B branch office. In between R1 and R2, I'm using 10.1.12.0/24. 10.1.23.0/24. Now for LAN traffic, I'm creating some loopback interface. So 1.1.1.1/32 and 3.3.3.3. Let's create one more loopback. Okay, wait. One more loopback on R3. Site B branch office 30.1/24. Here I'm creating one more loopback 192.168 10.1/24. So we have two networks on both branch office. Let's prepare this topology, okay? We are trying to do the basic configuration first. What is basic configuration means? IP
IP
address
address.
configuration. And from each branch office, I'm trying to configure default route towards ISP. Default route towards ISP. Why? To create a connectivity from this source public IP to this destination public IP, right? Because
Yes,
for
sir.
VPN implementation, we need two information, source public IP and destination public IP.
Yes, yes.
Wait, so let's prepare this topology first. Okay, let's just start our configuration with R1. So this is R1, host name is a site A, branch office, interface, fast Ethernet 0/0. As per design 10.1.12/24, no shutdown. We can create loopback interface 1.1.1.1 mask. Now interface loopback 192.168 10.1/24. show IP interface brief. Let's go to R2 router. Interface fast Ethernet 0/0. 10.1.12.2 mask. No shutdown. 0/1. 10.1.23.1 mask. No shutdown. Show IP interface brief. Let's go to R3. This is site B branch office. Site B 0/1 10.1.23. No shutdown. Interface loopback 0 3.3.3.3/32. Loopback 1 192.168.30.1/24. Now let's configure default route. So from R1, from site A, towards ISP, towards R2, I'm configuring default route. So for any unknown destination, 12.2 is the next hop IP. Now IP route for any unknown destination. 10.1.23.1 is the next hop IP. Akbar, any problem in basic configuration?
No, sir, it's clear.
Okay, so let's verify our basic connectivity. What is basic connectivity? So I'm trying to verify, this is site A branch office. So I'm trying to verify my connectivity with site B branch office public facing interface IP. So this is public facing interface. I'm here, I'm on site A branch office. I'm trying to verify my connectivity with site B branch office public facing interface. And here we are using 10.1.23.2. Can you hear me, Akbar?
Yes, sir.
Okay.
Yes, sir.
So now let's verify our connectivity. Let's verify our connectivity is 10.1.20. Yes, we have a reachability. So I
Yes.
can ping to other branch office public IP. This is a real scenario. Okay, you have one branch office in Noida, one branch office in Bangalore. You want to connect these two branch offices. So through VPN connection, so you need to verify your connectivity with public IP. So you have a
Yes.
reachability with public IP. Now, but you can also verify you cannot ping, you cannot communicate with LAN side network. See, I'm trying to ping 3.3.3 with source 1.1.1. So LAN
Will
traffic
not
is
be.
not traveling through this
Yes.
to R1. You can see traffic is not traveling.
Yes.
So we have a topology. Into this topology, we have a connectivity, but only in between public to public IP.
Yes.
Let's try to establish our private tunnel. And through this tunnel, yes, we can decide. We can decide what traffic we want to allow through this VPN tunnel. So for phase one, I told you complete configuration is divided into two phases, IPsec phase one and IPsec phase two, right? So in phase one, we
Yes.
can generate our session key. Let's generate our session key. Command is what? To generate our session key, crypto ISA KMP. Crypto ISA KMP key. And now you can define your key. For example, I'm using key CCIE123. And this key I want to exchange. This is session key. This key I want to exchange with address 10.1.23. Okay, with this command, what I'm saying, this is my session key. Okay, and this session key I want to exchange with this particular public IP. Akbar.
Yes, sir.
This is how to generate our session key. This is session key command. Once you generate your session key, what is your next step? Your next step is to exchange your session key. And to exchange session key, we can set up our phase one tunnel. Phase one tunnel. So let's create our phase one tunnel command crypto isaac kmp policy. If you type question mark, you can get a big number information. You have a big number. You can create 1 to 10,000 phase one tunnel. So I'm creating my first tunnel here. And into this tunnel, I can define parameters. For example, here I'm using for encryption. For encryption, yes, you can type question mark. You have option for encryption. So I'm using triple dash, for example. For hashing, yes, we have SHA, MD5 and SHA. So I'm looking for SHA. For authentication key, yes, I'm using pre-shared key method. And for Diffie-Hellman group, so we have group 1, 2, and 5. What is Diffie-Hellman group? With
Yes.
Diffie-Hellman
So
group, you can define the size of the session key. Okay. If I'm using Diffie-Hellman group 1, for example, if I'm using Diffie-Hellman group 1, so our session key size is what? 768 bit. If I'm using Diffie-Hellman group 2, so our session key size is what? 1024 bit. And Diffie-Hellman group 5, 1536. Akbar.
yes, sir. Yes, sir.
Okay, so you can do Google after this session. Diffie-Hellman key size. So what I'm
Yes.
doing, I'm trying to use session key size, for example, medium size of key. So I'm using Diffie-Hellman size is 2. Because if you are using higher number of keys, then it will take time to encrypt and decrypt your data. So I'm using medium size of the key, Diffie-Hellman group 2. Done. Your phase 1. Let me show you show run. Let's verify our session key and phase 1 tunnel information. So this is our session key. This is our session key. And this is our phase 1 tunnel. Where is hashing? Okay, wait. Hashing MD5 show run. So for hashing, I'm using MD5. Yes, so encryption, hashing, authentication method, Diffie-Hellman group 2. So this command is for phase 1 tunnel configuration. And this is your session key configuration. So session key and phase 1 tunnel is complete. Akbar.
Sir, what about pre-shared key? You don't mention any pre-shared key.
Pre-shared key. This is pre-shared key. Your
Okay,
session
okay.
key is your key. And
Okay.
pre-shared key is a method. It's not a key.
Uh,
Pre-share is a method, Akbar.
to get
It means
established the
it means
first
if I'm
tunnel.
using this method, it means I'm using same session key on both branch office.
To get established the phase 1.
Yes. Yes. In phase
Then
1
after
tunnel,
that,
you can define your authentication key method.
yes,
This
sir.
is just
After
a
that,
method. This is not a key.
yes,
Okay.
after that, the system will generate the key.
Sorry, can you repeat again?
After that, once the session key is established, they will make a, they will
Behalf of
generate
this
a key.
CCNA, behalf of this CCNA 1 2 CCI 123, it will generate a session key. Okay. It will generate a session key.
Yes.
And you are using same key, CCI 123 on branch office A and on
Okay.
side B, CCI 123. We are using same session key. That's why method I'm using what? Pre-share.
Pre-shared key.
Now let's talk about phase 2 tunnel. Phase 2 tunnel. So for phase 2 tunnel, crypto IPsec. For phase 2 tunnel, command is crypto IPsec transform set. What is transform set? It's a combination set. It's a combination set, you can say, or it's a combination, you can say. So first you
Yes.
can give a name for this combination. So I'm using a name TS, this combination name. Now question mark. Now you can define your protocol. So as I said, in phase 2,
ESP.
we have a protocol ESP, right? But
Yes.
you can also go with AH,
Yes.
authentication header. AH is
Yes.
not popular. Why? Because AH will
Encryption.
provide you only hashing. It will
Hash.
not provide you encryption.
Yes.
But if you go with the ESP protocol, ESP will provide you encryption. ESP will provide you hashing. That's why ESP is a popular option. So I'm using ESP triple dash ESP MD5. Now, exit. Now we can define our interesting traffic. Which traffic I want to allow through this VPN tunnel. So I want to allow and to match our traffic. This is Cisco router. To match our traffic, we can configure access list. So I'm using a command access list. And now I'm using a number 100. 100 means what, Akbar? I'm trying
Is
to
that
configure extended access list. This
yes.
is what? Extended access list. It means I can define source IP and destination IP. So access list 100, format, IP, source. Yes, I can define. Source is 1.1.1.1. If 1.1.1 is trying to communicate with this destination, if traffic is
Yes.
what? If source is 1.1.1 and destination is 3.3.3. So yes, I can create access list. So now what we have phase one tunnel, session key, phase two tunnel, and interesting traffic, right, Akbar?
Yes, yes, sir. Clear.
Now let's map all the configuration with each other. Let's try to map all the configuration with each other. So how to
Okay,
map?
okay.
For mapping, we have a command crypto map. Crypto map is a command to map all the configuration with each other. Now crypto map, and now you can give a name for this crypto map. So I'm using CMAP1, just a name, just a name. Now IPsec crypto map, CMAP. Okay, we can give a number. I'm creating first crypto map here. So I'm giving a name. Now IPsec ISA KMP. ISA KMP. So now what we have crypto map, and I'm creating my first crypto map. And this is IPsec ISA KMP crypto map. When you press enter, you are getting a notification message. This new crypto map will remain disabled until a peer and valid access list have been configured. So what I'm
Okay.
saying here, I'm saying please match address.
Okay.
Please match address. What? 100.
100.
Please match 100. And if 100 match, it means what? If source is 1.1.1, destination is 3.3.3. So please match 100. And if 100 match, if 100 match, then please set peer address, peer address 10.1.23.2. This is side B branch office, public facing interface IP. Set peer 10.1.23.2. Set transform set. Transform set is what? TS. TS. Press enter. Now exit. Exit. Now this crypto map we can apply on public facing interface. So in our topology, our public facing interface is fast Ethernet 0/0. How to apply this crypto map? Crypto map. And what is crypto map name? CMAP. Let's copy this crypto map and we can apply. We are getting a message here. Isaac MP is on.
On.
Now let's copy this configuration. This configuration can help you for side B configuration. Let's copy this configuration bit. Okay, now. So this is our session key configuration command. This
Yes.
configuration I'm trying to paste in R3. So for R3, this is what remote branch office, and here we are using 10.1.12.1. So let's change address information. So 12.1 is a remote branch office. Phase 1 tunnel configuration. So I'm not changing anything. We are using same parameter. Same
Yes.
parameter here. Now for ACL, yes, now source is 3.3.3 and destination is 1.1.1. Now transform set, yes, I'm using same parameter, triple dash and MD5. Crypto map we can create and peer address. Yes, peer address is 12.1 for R3. Now let's copy this configuration and we can paste on site B branch office. Wait. Now this crypto map I can apply on public facing interface. Interface fast Ethernet 0/1. Crypto map and crypto map name is what? CLAN. You can see now, Akbar, we are getting a message ISA camp is on, right?
Yes.
Let's start our verification. So we can start our verification with phase one tunnel. Phase one tunnel. So show crypto map ISA KMP SHA. So this command you can use to verify your phase one tunnel. This is what show crypto ISA KMP SHA. What is SHA? Security Association. So when you press enter, right now we don't have any tunnel. Right now we don't have any phase one tunnel. You can also verify show crypto ISA KMP SHA. ISA KMP SHA. So here
Not
what we have,
understand.
we don't have any tunnel. So okay, you can also verify your phase two tunnel. Show crypto IPsec SHA command you can use to verify your phase two tunnel. So right now, no traffic is encrypted, 0, and no traffic is decrypted. Okay, so nothing is traveling right now. So before initiate our traffic, let's try to capture our background process. Okay, let's try to capture packet in Wireshark so we can verify in a detailed information. Wait. Okay, so let's initiate our traffic. From site A, I'm initiating my traffic. And before initiate this traffic, let's check now. Wait. Before initiate this traffic, you can verify your wait. So this communication success rate was 0%, right? This time,
Yes.
if I'm initiating my traffic, if I'm trying to ping 3.3.3 with source 1.1.1 this time. So now I have my private tunnel, VPN tunnel. So I can allow any traffic through my tunnel. You can press enter. So this time I'm getting reply. Traffic is allowed through your VPN tunnel. You can press enter, see 100%.
Yes.
So you can verify your phase one tunnel information. Show crypto Isaac MP Shah. Isaac MP Shah. So yes, you have a tunnel. You have a tunnel in between this source public IP to this destination public IP. Yes, source public IP is what? 10.1.12.1, right? And
Yes.
destination
This is
public IP is site B branch office.
yes.
So you have a tunnel in between this source public IP to this destination public IP. This is QM. This is called mode, quick mode. State is idle state, and status of this tunnel right now is active. You can also verify your phase 2 tunnel information, show crypto IP6 SHA. With this command, you can verify your traffic information. So 9 packet is encrypted, 9 packet decrypted. Yes. Yes, you can verify 4 and 5, 9 packet. You can initiate more traffic here. You can initiate more traffic, 5 more traffic. So you can verify 9 and 5, 14. See, 14 packets are encrypted and 14 packets are decrypted. Let's go to Wireshark. So for example, I'm an attacker, okay? I want to verify what's going on in between site A and site B because traffic is traveling through public network, right?
Yes.
So if attacker, my point is what if attacker is trying to capture traffic information in between site A and site B, what information he can get? What information? So you can see now, this is what Isaac EMP protocol. This is your phase one tunnel protocol, Isaac EMP. So in
Yes.
phase one, this is what phase one. In phase one, they will exchange 9 packets in background. See, packet number 1, 2, 3, 4, 5, 6, 7, 8, and 9.
Then,
So in phase one, they will exchange 9 packets. They will exchange 9 packets. First six packets First 6 packets are called main mode. Okay. First 6 packets are called what? Main mode. And last 3 packets are quick mode. This is what?
quick
Quick
mode.
mode. Now, if you try to, for example, I'm attacker, okay, I'm trying to verify, okay. I want to verify what's going on, what traffic is traveling. So you can select this packet, you can open this packet information. So yes, I can verify traffic is traveling in between this. Traffic is traveling in between this source public IP to this destination public IP. And port number, source port number is UDP 500, destination is UDP 500. So this is Isaac MP protocol, right? Okay, Isaac MP, Internet Security Association and Key Management Protocol. This is Isaac MP. If you expand this protocol information, so you can go in, let's go in flag. See, in flag, you can verify not encrypted. This first packet is not encrypted. Akbar. Akbar, can you hear me?
Yes, yes, sir. Yes, I'm hearing you.
Okay.
I put
This,
my
this,
I put my mic off.
okay, no problem. This first
Okay.
packet is what? Is not encrypted. You can see here. This first
Yes.
packet is not encrypted. This first packet is not encrypted. If you check your second packet or third packet, for example, so packet is not encrypted. So if you check your fourth packet also, it's also not encrypted. So first 4 packets, remember always, first 4 packets are not encrypted. See, so no problem. They are not exchanging any information. They are just sending a blank packet. Akbar.
Yes. Yes, sir.
In
Yes.
here, what they are doing? What they are doing? Side A and side B. Side A is sending a hello packet to side B. It's trying to verify side B is available or up or not. And side B will give a reply packet. Then side B will send a hello packet to side B to check other branch office is available or not. And reply packet. So 1, 2, 3, and 4. So first four packet, they are not exchanging any parameters.
Yes.
Okay, they are not exchanging any information. They are just sending a blank packet. Now, if you check your fifth packet, so you can see now, okay, let's verify this fourth packet again. So you can see here we have some payload something information this side. Now,
Yes.
if you check your fifth packet, so your fifth packet is what? Encrypted. And now there's no any information this side. So
Yes.
fourth packet is fifth packet. Fifth packet is what? It is in an encrypted format. Now, this is what your phase one. This is your phase one. So what about data traffic, LAN traffic? See, We have
ESP.
ESP protocol. We have what? ESP protocol.
ESP.
Let's initiate a new packet. Okay, wait. Let's initiate new traffic. I'm trying to ping 3.3.3.3, and yes, we have some packet, ESP packet this side. This is your phase two tunnel. So now if you expend any packet, you can verify now, source public IP and destination public IP
Yes.
and ESP protocol encapsulating security payload. So if I'm trying to verify what information is traveling, I can't find anything. What is the packet header? If you check the complete packet header here, so attacker can only get source public IP. Source public IP is what? 10.1.12.1 and 10.1.23. Source public IP and destination public IP. Attacker can get ESP protocol. And after ESP, what exactly the traffic here we have in background? So traffic is what? 1.1.1.1. It's trying to communicate with 3.3.3, right?
Yes.
So attacker can only get this information. After ESP, everything is encrypted. So attacker can get only source public IP because it's a publicly available, destination public IP, ESP protocol, yes. But after ESP, everything is encrypted. Clear
Okay.
now? This practical implementation.
Yes, sir. Clear.
This
Clear.
is what our side-to-side
Yeah.
VPN implementation. But here we have some problem. Into this design, we have some issue. The issue is what? If I'm trying to verify my connectivity, for example, yes, I'm getting reply, right?
Yes, sir.
So 3.3.3 can communicate with 1.1.1. No problem.
Yes.
But in case if I'm trying to verify my connectivity with 30.1, with source 1.1.1, for example, so this traffic is not traveling.
Yes.
This traffic is not traveling. Why? Because as per your configuration,
Know that.
your ACL configuration, your ACL configuration, only this source and this destination can
Yes.
communicate through this VPN tunnel. If you want to
Yes.
allow, for example, if I'm trying to verify my connectivity with 192.168.10.1, so I'm trying to verify my connectivity with this source IP to this destination IP, and I'm not getting reply. So to allow this traffic, what we can do, we can create ACL entry. We can add this entry, access list 100, format IP host 192.1, no, yes, 10.1, destination 192.168.30. Let's go to R3 branch office, access list 100, format IP
192.168.
192.168.30.1, 192.168.10.1. Now you can try. You can try, and first you can check your access list. You can check your configuration, access list configuration. Now, if I'm trying to verify my connectivity this time, traffic is traveling.
Yes.
So what is the problem? What's the problem we have into this topology? So into this topology, this is what policy-based VPN. Okay, policy-based VPN. The problem into this topology is what? If I have multiple networks, Akbar,
Yes,
if
sir.
I
Yes.
have
Yes, I.
multiple source IP, destination IP, source IP, destination IP. So I need to create all entry. For example, this side I have 100 network or 100 different host IP. This side I have 100 host different IP. So on each branch office, I need to add entry, source IP, destination IP, source IP, destination IP, source IP, destination IP, right?
Yes, yes.
It is a very difficult task. That's why what we can do, that's why we can go with the next implementation, next VPN implementation. This is called GRE implementation. That's why we can go with route-based VPN. We can go with GRE implementation. So this is our first practical implementation. I hope it's clear for you.
Yes, clear, sir, clear.
Side-to-side VPN implementation. Side-to-side VPN implementation. Now next we can focus on GRE. This is not only GRE, this is GRE,
With
then
IPsec.
MGRE, MGRE, and GRE with IPsec.
Yes.
So this implementation we can discuss in next session, okay? And
Okay, sir.
next Saturday, I think I'm not available. I will update you, okay? We can
Okay,
do
sir.
our
Okay.
session on Sunday. But I
Okay,
will
no
update you. I
issue.
will update you for this, okay?
Okay, sir. Okay.
Sunday, yes, we'll do our session, but Saturday I'm not available.
Okay, okay, sir. Just update
I
me
will
if you are
update you. I
available.
will update you on WhatsApp. This
Okay, sir.
this
Thank you.
video I'm sharing with you. After
Okay,
after
thank
10
you.
to 15 minutes, Akbar.
Okay, thank you. Thank you. Take
Bye,
your
bye
time.
dear. Take care. Bye.